For many centuries, humanity believed it already understood how vision worked. Ancient scholars taught that the eyes actively sent invisible rays outward, touching objects in the world and bringing information back to the mind. This idea was elegant, intuitive, and deeply ingrained. It appeared in classical texts, was taught in schools, and repeated by respected authorities. Over time, it became so familiar that questioning it felt unnecessary. Yet familiarity is not evidence. In the 10th century, one man chose to challenge what everyone else accepted. His name was Ibn al-Haytham, later known in Europe as Alhazen. Born in Basra and later working in Cairo, Ibn al-Haytham lived in an intellectual world shaped by inherited wisdom. Philosophy, mathematics, and theology often blended together, and ancient thinkers such as Aristotle were treated almost as unquestionable sources of truth. Knowledge was frequently built by commentary, by explaining what earlier authorities had said, rather than by confronting nature directly. Ibn al-Haytham believed this approach was incomplete. He held a quietly radical conviction: truth does not belong to authority. It belongs to reality. And reality can only be understood through careful observation and testing. This conviction led him to a deceptively simple question, one that would unsettle centuries of belief: how do human beings actually see? According to the dominant theory, vision occurred because rays emerged from the eyes and struck objects. The eye, in this view, was active, projecting perception outward. But Ibn al-Haytham noticed contradictions everywhere. If sight depended on rays leaving the eye, why did intense light cause pain instead of sharper vision? Why did sudden brightness overwhelm the eye? Why was vision impossible in complete darkness if the eye itself produced the rays? These were not philosophical curiosities. They were physical inconsistencies. Rather than argue with scholars or write counter-commentaries, Ibn al-Haytham chose a more demanding path. He turned to experimentation. He believed that nature, if questioned patiently and honestly, would provide clearer answers than any book. He began by controlling light itself. He darkened rooms entirely, eliminating all external illumination. He then allowed light to enter through small, carefully measured openings. He observed how images formed on walls, how shapes appeared inverted, and how brightness changed with distance and angle. He studied shadows and noted their sharpness and movement. He examined mirrors of different shapes and materials, watching how reflections behaved. He passed light through water, glass, and transparent crystals, recording how it bent and dispersed. He repeated these experiments again and again, altering one condition at a time. Slowly, a pattern emerged, one that could not be ignored. Light traveled in straight lines unless something caused it to bend. Light reflected predictably from smooth surfaces. Light refracted when moving between different substances. And crucially, light always moved toward the eye. From this evidence, Ibn al-Haytham reached a conclusion that overturned centuries of accepted belief: vision does not occur because the eye sends rays outward. Vision occurs because light reflects off objects in the world and enters the eye. The eye is not a projector, it is a receiver. This insight marked a turning point in human understanding. But Ibn al-Haytham did not stop at light alone. He turned his attention to the eye itself. He studied its structure, describing its components with remarkable precision for his era. He recognized the importance of the retina in receiving visual information and the optic nerve in transmitting it to the brain. Sight, he argued, was not instantaneous or mystical. It was a physical process governed by natural laws, combining light, anatomy, and perception. By grounding vision in observation and experiment, Ibn al-Haytham transformed optics from speculative philosophy into an empirical science. Yet even this achievement represents only part of his legacy. Because what truly separated Ibn al-Haytham from those who came before him was not simply what he discovered, but how he insisted discovery must happen. And it was this insistence that would quietly reshape the future of human knowledge. The true revolution of Ibn al-Haytham's work did not lie only in his conclusions about light and vision. It lay in the intellectual discipline he demanded from anyone who claimed to seek truth. In an age where knowledge was often inherited rather than tested, he insisted on something profoundly uncomfortable: ideas must earn their credibility through evidence. In his monumental work, The Book of Optics, he did not simply present results. He documented a method. He explained that investigation must begin with observation, proceed through careful reasoning, and be tested by controlled experiment. Hypotheses were not to be admired for elegance but challenged for weakness. Conclusions were not final unless they could survive repetition and scrutiny. Even more striking was his attitude toward authority. Ibn al-Haytham warned that the seeker of truth must make himself an enemy of all he reads. He believed that admiration for great thinkers could become an obstacle to understanding. To read critically, to doubt respectfully, and to test relentlessly, this was the moral duty of anyone pursuing knowledge. Centuries later, this mindset would be recognized as the foundation of the scientific method. But in Ibn al-Haytham's time, it stood in quiet opposition to tradition. Ironically, some of his most productive years emerged not from freedom, but from confinement. After proposing an ambitious plan to regulate the flooding of the Nile, a project that proved unworkable, he fell out of favor with political authorities. To avoid harsher punishment, he lived under house arrest for years, removed from public life and official work. What remained was solitude. Instead of despair, he transformed isolation into opportunity. His home became a laboratory. Simple tools replaced grand institutions. Without distraction or expectation, he devoted himself entirely to observation, experimentation, and writing. The absence of external authority only strengthened his commitment to evidence. In confinement, his ideas matured. He refined his experiments, clarified his arguments, and produced works that would outlive empires. What was meant to silence him instead gave him the conditions to think more deeply than ever before. When his writings eventually traveled beyond the Islamic world, their impact was profound. Translated into Latin during the Middle Ages, the Book of Optics became a cornerstone of European scholarship. Roger Bacon embraced its experimental philosophy. Johannes Kepler built upon its optical principles to explain how lenses and the human eye truly function. Even Leonardo da Vinci absorbed concepts rooted in Ibn al-Haytham's careful study of light and perception. Yet history often favors the visible over the foundational. Today, modern cameras, microscopes, telescopes, eyeglasses, and imaging technologies all rely on principles Ibn al-Haytham articulated more than 1,000 years ago. More importantly, every scientific experiment that values evidence over assumption follows the intellectual path he helped define. He did not seek fame. He did not argue endlessly. He did not trust tradition blindly. He observed. He tested. He revised. In a world eager for certainty, Ibn al-Haytham chose patience. In a culture shaped by authority, he chose evidence. In an age of inherited answers, he asked nature to respond. And by doing so, he did more than explain how humans see the world. He taught humanity how to understand it.